Hello and thanks for watching Best Maths Tutors. We're going to do our second live stream, and this time it's going to be on simultaneous equations, and we're going to look at two different types of solving them. So we're going to look at the elimination method. So there it is. There's the elimination method, and we're also going to look at the substitution method. So the both of these are around on the GCSE papers around the grade 5 mark. So that's where we're looking at on the somewhere between the higher tier and the foundation tier, top end of the foundation tier, and lower end of the higher tier. So we've also got other methods we can use to solve simultaneous equations. So we could use graphical methods. But we're going to try and cover that in a further video. So I'm going to start to look at some actual questions. So we've got simultaneous equations here. I'm going to use the elimination method to solve these. And we can see what makes this a simultaneous equation is that we actually have two variables. So in a simultaneous equation, there's two or more variables, and what I mean by that is unknowns is another way of saying that. So two or more unknowns, and we can see in this first one we've got both x's and y's, you see. So x's and y's, and so in order to solve that we actually need two equations to do it. So we've got to have two equations. If we only had one equation, then we wouldn't be able to solve this. So the way we do it by elimination is we usually subtract one of the equations from the other, and we need to look at the coefficients on the x's and the y's. So the coefficients, and the coefficients means the numbers that is multiplying the x's or the y's. So we can see in the first one, we've got 5x. So the coefficient would actually be the 5. And we've got a 3y. So the coefficient for the y in the first equation is 3. And if we end up with, in either of the two equations we've got, the same coefficient for either the x or the y, so we can see here we've got the same coefficient for the y's there. It makes it a fairly simple, or a more simple operation. So we're trying to eliminate, in this case, so this is the elimination method. So we're trying to eliminate y in this first one. And to do that, I'm going to just subtract the second equation, so this one, from the first equation. And if we do that, we can see we've got 5x take away 2x, and that will give me 3x. And if we take away 3y from 3y, then what that does, which is what we want, it eliminates the y's, because 3y take away 3y is actually going to be 0y. So we can ignore the y part now. And we've then got 41 take away 20. 41 take away 20 is 21. And now we've got a simple equation. We've got rid of the y, and we've got an equation with only x in it. So we can just divide both sides of this equation by 3, and we end up with the 3's will cancel, and we end up with x is equal to 7. So we're partially there, but what we need to do now is we need to try and substitute back into either the first or the second equation. So I'm going to pick the simpler one of these, which is the second equation. So I'm going to substitute my value that I've just found for x, substitute x equals 7 into the second equation, into the one I've labelled 2 there. So if I do that, then what I will get is, I will get that I've got 2x, sorry, I can replace the x is what I mean to say. So 2 times the 7, so instead of writing x, I'm going to write the 7, plus 3y is equal to 20. And now if I multiply the 2 and the 7 together, it's 14 plus 3y equals 20. And if I subtract 14 from both sides, take away 14 from both sides, then I end up with 3y equals 16, equals 6, sorry. And if I now divide both sides by 3, then what I'm going to end up with is that, so just divide both sides by 3, and I'll end up with the 3's cancel, and end up with y is equal to 2. So there are my two answers, y equals 2 and x equals 7. So that's the first one completed. I'm just I'm looking at another example next, and this is one which looks very similar to begin with, i.e. we've got the same coefficient for the y's there, so we've got same coefficient for y, so we can see it's we've got for y, and we can see it equals 3 is the coefficient for y. But we can see we've got the signs are different. So we've got a plus 3y and we've got a minus 3y. So we've got different signs. And that's quite important. So if we have different signs, what we do this time is instead of subtracting the equations, we actually add the equations now. So this time what we do is different signs means we will add the equations. So if we do that, we've got 4x plus x will give me 5x. And then what we're going to do is we've got plus 3y and then plus minus 3y. And I'll just do this over here just to show what I mean. We've got positive 3y from the first equation, and then we're going to add negative 3y from the second, and then we're going to end up with 3y and a plus and minus together make minus. So that's why we're choosing to add these two equations. And then we can see that 3y take away 3y is actually going to equal 0. So the y's cancel if we subtract the second one from the first one. And then if we subtract there, we've got, if we add, then what we end up with is 18 plus 7 is 25. So we've added the second equation to the first equation. So if 5x equals 25, then what we can do, we want to get x on its own. So divide both sides by 5, and then the 5's will disappear. And then we end up with just x on the left-hand side. And 25 divided by 5 will give me 5. So with that value we've got for x, we're then going to put it into one of the two equations. So if I label these equation 1, equation 2, I'm going to sub x equals 5 into equation 2. And I'm putting it into equation 2. I can put it into either one, it doesn't actually matter. But if I put it into equation 2, that's the simpler one. I can see I've got just x there. So that makes that a little bit easier. So I've got 5 replacing the x, minus 3y equals 7. Now I need to rearrange this one a little bit. So I'm going to just get the minus 3y on its own first of all. So I'm going to take away 5 from both sides. There's a few different ways of solving something like this, but this is one of the ways the way I would choose. So take away 5 from both sides, and we can see we end up with 0 there. So the 5's have disappeared. And if we then have minus 3y and that's going to equal to 2. So we're nearly there. And then if we, so from that, we've got minus 3y equals 2. I'm now just going to divide through by the minus 3. And so I'm going to end up with y equals minus 2/3. So that's that one done. So we've got our two values there, x equals 5 and y equals minus 2/3. So we're now going to look at slightly more complicated ones. So in this case, we've got to solve these simultaneous equations. Now, these are a little bit more complicated, and the reason why these are more complicated is because the coefficients are different. If we look at these, we can see that we've got a 1x there, we've got 5x there, and we've got a minus 3y and a 2y. So none of the coefficients are the same. So what we can actually do is multiply, in the case when the coefficients are different, and I do apologise for my scruffy writing here. So in the case where the coefficients are different, what we have to do is multiply either one or both of the equations to make the coefficients the same. So we want to try and do that, make the coefficients the same. And we can see in this case the easiest thing to do would be to multiply this first equation. If I label 1 and 2, would be to multiply the first equation by 5, and then that will give us a 5x in both cases. So I'm going to times that one by 5, and so if I do that, so I've got to multiply every part of that first equation by 5, and I'll end up with 5x minus 15y, and if I times the 23 by 5, I'm just going to do this so I don't make any mistakes. 23 times by 5, so let's try that. That's going to be 5, and then 3 times 5 is 15, 5 times 2 is 10, so 115. So we're going to, that's still going to be a minus, that's minus 115. And I'm just going to write equation 2 above that. So I've got 5x and then plus 2y equals 4. So now if I subtract this one, the second one I've created from this one, I'm going to take away, because the coefficients of the x's have the same value and the same sign, I'm going to take away. So the x's will disappear. We'll end up with 2y minus 15y, but it's take away minus 15y. So that becomes 17y. And we're going to get 4 minus 115, and that's going to make 119. So to find out what y is, what we've got to do is we've got to divide the 119 by 17, and we actually get 7. So that's the value for y. And then all we're going to do is we're going to put that into one of the original equations. So I'm just going to pick the first of the equations. So I'm going to pick this one. So I'm going to say that x minus 3 times the 7, which is the y, is equal to minus 23. So that's just replacing the y by 7. So I've got x minus 21 equals minus 23. And if I add 21 to both sides, that will give me the 21's cancel out there. I'll end up with x equals minus 21, minus 23 plus 21 is going to equal to minus 2. So there are my two answers. I've got y equals 7, and I've got x equals minus 2. I'm just going to look at this this next example, because we might wonder as well, here again the coefficients are different, but what we might wonder is, well, in this case, can we get them to be the same by multiplying just one of the equations? In this case we can't, and so we might have to multiply both in this case. So this time we've got to multiply both equations. So what I'm going to do is I'm going to try and make the coefficient of the y the same. So we can see the coefficient on the first equation is 2, and the coefficient on the second equation is 3. So I'm looking for a common multiple of these two numbers. If I times the 2 by 3, I will get 6. And if I times the 3 by 2, I would also get 6. So that means what I need to do is times the top equation by 3 and times the bottom equation by 2. And what that will give me is, for the first one, I'll get 12x plus 6y equals 30. And for the second equation, what I'm going to get is that 10x plus 6y equals 24. So that's great now, because I've got the same coefficient for y. I've got the same coefficient, I'll just abbreviate that to that, for y. And now, if I subtract them from each other, I'm going to get 12x, take away 10x is 2x. The y's will cancel, and what I'll get is equals 6. So, so now I'm just going to divide through by 2. Divide through by 2, and what that will give me is that x equals 3. And so we then replace the x in either of these first two equations, and that will give us what y is. So I'm going to pick the first equation. So what that will give me is 4 times 3 plus 2y equals 10. And it's better to go back to the original equations, which are simpler. So, okay, if we rather than the ones we've multiplied up. So don't put the value for the x into either of these two. Go back to the beginning and put them into there. So now what we're going to get is 4 times 3 is 12 plus 2y equals 10. So now I'm going to take away 12 from both sides and move the board up a little. So that will give me that 2y equals minus 2, and that y is equal to, if I divide both sides by 2, I'll get y is equal to minus 1. So my two answers for this are the x equals 3 from before, and the y equals minus 1 from before that we just worked out. Sorry. So we've got x equals 3, y equals minus 1. So I'm now going to just look at this in terms of it being a word problem. So we can use simultaneous equations to solve word problems like this. Now, it might not be immediately apparent that this is a word problem, a simultaneous equation problem. But if we read it, we can see we've got 175 sweets in 4 small packs and 3 big packs, and 154 sweets in 5 small packs and 2 big packs. So what I can do is I can try and use a little bit of algebra for this. So I'm going to create an equation out of these 2 bits of information. So I'm going to use S to represent a small pack, and I'm going to use B to represent a big pack. So I'm going to create an equation. So if I do that, from the first line, this line here, I can say that I've got 4 S, which means 4 small packs, plus 3B, which means 3 big packs, is equal to 175. And from the second one there, I've got 5 small packs, and I've got 2 big packs, and that is equal to 154. So we've created something very similar to the equations which we had earlier. Now looking at this, we can see again we don't have equal coefficients, so the coefficients aren't equal. So because they're not equal, that would mean we need to multiply one or both to create equal coefficients. And so I'm going to target the B here. So we've got a 3 and we've got a 2. So 3 and a 2 are the coefficients for the B. So what I'm going to do is I'm going to times the top one by 2, which will give me a 6, and times the bottom one by 3, which will also give me a 6, which is what I want, because I want the coefficients to be the same. So if I do that, so times in all of this one by the 2, and times in this one by the 3, then the top one is going to end up being 8s plus 6b is equal to, and 175 times 2 is equal to 350. And if we do the same for the bottom one, times by 3 this time, I've got 3 times 5s, 15s. 3 times 2b is going to give us 6b, which is good because that's the same as the one above. So I've got the same coefficient. And then 3 times 154, I'm just going to do that on the calculator actually. So 3 times 154, and so we get 462. So 462, and so what that would mean then is we've now got to subtract one from the other to get rid of the b's. And just to make it easier, I'm actually going to write this one below that because we'll end up with a positive number of s's if we subtract it. So I'm going to do this question here. So subtract this 8s plus 6b from the line above. So we do that, we get 7s, the b's cancel, which is what we want, and that's equal to 112. So you can see that 0 from 2 is 2, 5 from 6 is 1, 112 there. So the next thing I need to do is just find out what s is. You can do that by dividing the 112 by 7. So if we do that, 7 goes into 1, it doesn't go into 1, but it goes into 11 once. The remainder is going to be 4, and so 7's into 42 is 6. So s is equal to 6, which means we've got 16 small packs. And if we want to find out the number of big packs, we're going to have to substitute that into one of the original equations. So I'm going to choose this one because that looks the simplest to me. Could again choose the other one and that should work. So we can say we replace the s by 16. We'll get 5 times 16 plus 2b equals 154. And just to make sure I do this on the calculator, so 5 times the 16, it should be 80. Yep, 80. So 5 times the 16 is 80, plus the 2b is 154. So I'll just move the board up a little. And take away this 80 from both sides. We end up with 2b is equal to, and that should be 74. And if we then want to get the b on its own, we have to just divide through by 2. So dividing that by 2 and dividing that by 2. So the 2's cancel, and we end up with b's into 74 is equal to 2's into 74 is 37. So what that tells us is we've got 37 big packs. Okay, so there's our answer to that one. And if we want to now look at the substitution method, so there's another method for doing this, and substitution is a very useful method, and sometimes the questions are set out so that we would use substitution. We can see really that this one is because that's in the form y equals. So if it's in the form y equals something or x equals something, then it's quite easy to use the substitution method. And what we can do, we replace the y in the first equation, so here, by 2x minus 7, because that's what we're told it's equal to in the second equation. So we end up with 2, and then instead of y, I'm just going to write a bracket, and I'm going to put this 2x minus 7 inside it, and then that's going to equal x plus 10. So we've got an equation which has only got x's in. So that's what's good about this. So if I multiply through by the 2 there in that first bracket, I'm going to go 2 times 2x, and that's going to give me 4x. And if I multiply the 2 by the minus 7 there, that's going to give me minus 14. And so that's equal to x plus 10. So what we've got is an equation now just in x's, and we're just going to try and solve that by getting the x's on one side and the numbers on the other. So I'm going to take away x from both sides, and I'm going to then get 3x on the left minus the 14 that's already there. The x's cancel. That's equal to 10. And moving that up, make sure that does look like a 10. So now I want to add 14 to both sides, and I'm going to end up with 3x equals 24. I then divide through by 3, and so we end up with the 3's cancelling. Doing the same thing to both sides is the method that we do in this. So we end up with 24 divided by 3 gives me x is equal to 8. And that's the x value that we've found. Well, now we need to find the other value, so now we need to find the y. And handily, it's in the form y equals some equation of x. And because we've got x equals 8, we can then replace the x in this. So we've got y is equal to 2, and instead of the x there, I'm going to write in the value that I've just found. I'm going to say it's 2 times the 8, and then minus 7, so the 7 that's already there. So all I've done is I've just replaced the x by 8, and if I multiply that out, I end up with 2 times 8 is 16, take away 7, and so that equals 9. So we've done it. So we've ended up with x equals 8 and y equals 9. And if we did want to do a little check, and we can do this with all of them, I was just sort of not trying to take too long over the video. If we put those values of x equals 8 and 9 into the first equation here, so we put them into this one, we should find it works. So I'll just change pen so we don't get confused with what I'm doing. But if I was to do a check, a final check now, what I could do is I could put my value of x equals 8 and y equals 9 into the first equation. And if we've done it right, it should work. So let's have a look at that and hope that I have actually done it right. So we've got 2 times the y value, so 2 times 9 should equal, if we've done it correctly, the x equals 8 plus the 10. So the left-hand side does give us 18, and the right-hand side gives us 18. So that shows we've got it correct, which is great. So we know we've got it right. And if you're in an exam and you've got enough time, it is handy to check your answers like that. Obviously, if you're under pressure and you're running out of time, then you may not have time to do this. So it just depends how quickly you get through a paper. So that's the end of our live stream, and I hope it's been useful to you. And if it has, please subscribe to our channel, because we're doing more live streams, hopefully on a weekly or fortnightly basis on Wednesdays, and also we've got many more videos. And so we do hope you like our live stream. So thank you for watching.